This episode was brought to you by Pentester Academy, the leader in online cybersecurity education. Join over 10,000 professionals from 90 countries to learn security online. Also brought to you by Hacker Arsenal, artillery for cyber warriors. Visit us on hackerarsenal.com to check out our latest attack defense gadgets. I'm Marley Oxenholm from Pentester Academy TV, and welcome to our show, Access Point, where we spotlight cybersecurity companies and give an inside look at the people and technology behind the latest advancements in the industry. I'm Marley Oxenholm here at Distil Networks, and I'm sitting down right now with Anna Westelius, who is Senior Director of Security Research. Thank you for joining me today.
Thank you very much.
Absolutely. All right, so first question here. Can you describe your bot detection product architecture? Is it an appliance or cloud-based service, and how is it incorporated into existing web application?
So we like to think of ourselves as deployment agnostic, meaning that we can deploy in almost any infrastructure. We do have a partnership with Verizon with Edgecast, so if you want to just direct your traffic to us, it's a simple DNS change and you're directed to our public cloud. Then we do private deployments where we set up either a private VPC or another infrastructure in front of your infrastructure through which we can point our traffic. We also have a JavaScript deployment method, which allows us just simply add our JavaScript snippet to your web applications wherever you want to put them, and then allow you to benefit from our core platform.
Wonderful. Okay. And now, how do you decide which is a good bot versus a bad bot? I know search engine bots have been around for decades, and websites want them to scrape. So how do you differentiate that?
So it's a lot about allowing customers to decide themselves how they want to control their traffic.
Okay.
So, for example, certain customers want to allow not very official good bots. So we allow them to make those changes and add that to our configuration so they can do that themselves. But for the large-scale good bots, we maintain and curate lists of non-good bots, and we always validate where they come from. So it's very common, actually, that people try and spoof the good bots. You pretend to be Google, you try and, seem like you're Google, but you're not. So Google provides, exactly where you should originate from if you're Google, and a lot of other different information that we can use to, identify them specifically.
Okay, got it. And now, is it possible for an attacker to create bots using web browser automation frameworks like Selenium? And since this would seem like a regular browser, how would your technology differentiate that?
So we use a lot of different methodologies to identify bots. There is, and I think in all security, you need to have a multi-layered approach to detection, so you can't only use one type of feature or binary checks. So part of our technology is what we call interrogating the browser. I like that word because it's like you kind of challenge it when it comes in to really validate that it's a person. And sure, Selenium, yes, would seem like a browser, but we check for so many different features in the browser itself, both that and how it behaves on the website, the usage, the behavior over time, and the way that it interacts with different resources. So it's really important when doing this type of detection that you're not solely relying on one thing. Because a lot of people say, oh, I can check the user agent, or I can check, that the browser is valid. But you have to use all these different things combined, that and knowing where the user should come from, what is expected on the specific domain, and the resources that we want to protect in order to be successful in mitigating things like Selenium.
Okay.
Selenium has also been around for a long time, so Selenium specifically, we can build specific identifiers to find, and we do so with a lot of the different headless browser technologies.
Okay, wonderful. And now, how are you using machine learning to make your bot detection smarter?
So we use machine learning in various portions of our detection. A lot of it has to do with finding anomalies in usage patterns and where users come from, how frequent they visit the sites, but also in terms of biometrics. So, browser mouse movements and the way that people interact with resources on the website. So like distance from and to certain interactions and the way that they move across, different resources.
Okay. And now, are you seeing attackers use adversarial machine learning techniques to counter machine learning detection algorithms?
So there is a lot of fun stories, right, about bots that, find other bots and they fight together. There is this one about the gas stations that got together and lowered each other's prices over the course of a day until gas was completely free. And that happens, right? If we put all our reliance on our machine learning, we would end up in situations where the bot fights the bots, right? And that would be an interesting Skynet situation. But that's why we don't rely solely on that particular problem. You have to continuously retrain your data in a way so that we teach the data what's true. Because if we just continuously feed it the information we're receiving, we would be teaching it what the bots are doing rather than what the users are doing. So as part of our machine learning framework, we actually have a lot of manual labeling and feedback, because we have an analyst team who do security analysis for our high-value customers, and they do manual investigations and security analysis. So the feedback and output from all their work is then fed into our machine learning framework in addition to everything else. So we don't have that in the same regard. But we do have a lot of back and forths too, both in terms of the machine learning counter attacks, so to speak, but especially when attackers really want to get to a certain resource. We have had situations where we've made changes to configurations, and only 2 minutes later we would see the attackers change their behavior and continuously try to attack. So it becomes a little bit of a rat and mouse game, cat and mouse game. But eventually, when you've introduced enough friction to attackers, it becomes too expensive for them to continue. So we really need to see everything that we introduce as a, more difficult or a cost to attackers.
Got it. That makes a lot of sense. Okay. And now I'm curious, why are regular CAPTCHA techniques failing to detect bots, and how is Distil CAPTCHA doing a better job technologically?
So traditional CAPTCHAs are fairly easy to solve. It's pretty easy to write a script to surpass almost any CAPTCHA technology out there. And there hasn't really been a lot of change in the CAPTCHA world for a very long time. Yep. So we actually partnered with a startup that started out of Australia who have reinvented the CAPTCHA technology. And they built this out specifically for us in our partnership as well. And so that uses a lot of machine learning features, a lot of different relearning capabilities on how to counter automation specifically, since so many people, build tools to specifically avoid the CAPTCHAs.
Okay, got it. And now I know API endpoints are usually consumed by apps running on mobile devices, and would assume their behavior is already like a bot, since they might be periodically sending and receiving information. How does your technology differentiate between this and malicious API bots?
So APIs is definitely a struggle, right, for everybody who's trying to deal with automation. Like you said, a lot of the time it's machine to machine, so how do you differentiate? Right. That's, again, why you need to have a multi-layered approach to security. So you have to not only look at the request features, not only the way that they interact, because they don't, right, in the same way. And so in part what we have done for native mobile apps specifically, we have developed an SDK that checks for a bunch of features on the device itself. So we more or less validate the device and then allow that to be part of our identification methods, that and usage, and not relying on IP addresses, and continuously just using all these different features to help secure the APIs. But what we also need to do when you do API security is work closely with the companies, because they have more control of their APIs than they do on their websites, because they own the way that the system interacts with each other, right? Because they develop the apps, so they can say, this is what is the behavior we expect, and then penalize anything outside of that.
And now, how do you protect against an application-level DDoS attack, and can you give an example where you did this for a customer?
So when we talk about application layer DDoS attacks, what we do specifically for those type of attacks is, validating the devices, right? So even if someone is distributing themselves vastly, we've seen situations where they have 200, 400,000 IP addresses, right? And they're generating quite little traffic per IP, but in terms of velocity, they end up in millions and billions of requests, which would have taken down almost any infrastructure. The fact that we, before even allowing them into the infrastructure, we validate whether or not it's a real browser and a human, you can remove that wherever you want in your infrastructure. And we work closely with our customers to identify long-term things that we can move out perhaps to other parts of their infrastructure as well. So if you want to block it at the edge, for example. We also curate and maintain a lot of information about IP space, because we have such a vast source of information with all of our customers, right? So whenever we see bad traffic originating from a specific location, we update our known lists of locations where they might originate from. We also curate lists of bad users. So the way we identify users, we maintain that information in a global database so they can't be reused in any of these situations.
Okay, makes sense. And lastly, are there any other interesting things that you'd like to highlight about the company?
Well, I think what makes us different in this space is, first of all, we've been around the longest, so we are the experts in this space, but we're also still in full company of startup, right? So we're flexible, we're able to evolve as the threat evolves. This is our core business. This is not something that we've added as an additional functionality that other companies, do as a checkbox. We really try and make our tech focusing on this problem and solving it for all of our customers. And I think that's really what makes us different from our competitors.
Wonderful. Thank you so much for sitting down and speaking with me today. I really appreciate it.
Thank you.
Absolutely. And that's all the time we have for today, so be sure to tune in next time for another episode of Access Points. Also, make sure to subscribe to our YouTube, Twitter, and Facebook so you don't miss out on any of the latest cybersecurity news. This episode is brought to you by Pentester Academy, the leader in online cybersecurity education. Join over 10,000 professionals from 90 countries to learn security online. Also brought to you by Hacker Arsenal, artillery for cyber warriors. Visit us on hackerarsenal.com to check out our latest attack defense gadgets. Thanks for watching, and we'll see you next time.